Alright guys, so we're going to talk about functions. Done with chapter 5. If you've taken the Intro to Programming courses, 1113, if you've used Python, you know what functions are. And a lot of this is going to seem real familiar, which is cool. Kind of go through it pretty quickly. And since it's a prereq, I hope that that's true of most of y'all. So modular program, the idea of breaking a program up into smaller manageable functions or modules. You might have a, get input. You're going to get a whole bunch of input, and then save input to file function. And then you might have another one, read input from file. And process input. You can divide it into modules, and it's easier to maintain. You could even put each one of those modules in a different program. We haven't been messing with header files, but we're going to do so on this one, so that we can stick the functions in a separate CPP file than our main one. So far, that's always what we've been doing, is creating one CPP file and putting all of our code in there. So a function is a collection of statements. It's a body of code that's got a name. That way, you can execute that body of code by a single call, by using that name in your main application. And as many times as you want to repeat it, you can just do that. So that way, if you have 200 lines of code, you don't have to copy and paste that into your main program in order to repeat that task over and over. Instead, you just put it in a function, and then you can access it with a single call. So their example. Here we go. We have a mass number of statements in a row. This is kind of silly, but there we go. So we could divide it up so that we've got a main method that calls a couple of statements, and then we have function 2, and then we have function 3, and we have function 4. Now what's silly about this example is that nothing calls function 2, and nothing calls function 3, nothing calls function 4. What main should call, what they should show is that main calls function 2, and a main calls function 3, and a main calls function 4, to get that to work. So defining and calling your functions. When you call the function, and some textbooks will call it an invocation, you will invoke it, that causes the function to run. And the function definition are the statements that make up the function, including the function header, where you define what kind of data it accepts as parameters and what it returns, and then the body of the function. There's also something known as the function prototype. The function prototype is where you define the header of the function, but you don't give it a body, because you're going to be giving the body somewhere else. And you can put the prototypes in the header file. And we'll get to that. So when you define your function, it'd be nice if we had an example right here. So I'm going to add one because they didn't. Well, we've seen int main. That could be our first example. There we go. And if all it did is, see out something like that, there we go. So it's got a return type. Main returns an int. It's got a name of the function. Main is the name of the function. It's got a parameter list. Well, this one doesn't. So you have an optional series of parameters that go in there. And then you have a body. The body goes between the braces, and it's all the lines of code that are associated with that function. Now that one's really boring because it doesn't have any parameters, right? So let's define another function. Int, I don't know, calc something. And it's going to take a parameter called x. And its body is going to be to calculate some value using x. I don't know what, but int y, or int r for return value, is equal to x times 2 plus 10, whatever. And then return r. So what is the return type of this function? Still int. What's the name of the function? Calc. What are the parameters? Well, main didn't have any parameters, but calc has one parameter. So when we're going to call that calc function, we put it in our client code. Our client code is the body of whatever code is going to be invoking it. So I would do this. Int ABC is equal to calculate 10. And then I could see out ABC. Like that. Obviously, this isn't a whole program. I mean, and what do I mean by that? It doesn't have the pound sign includes and using statements and things like that. But here, this is the invocation. It's where we call the function. Since the function has a return value, we can store that return value. If it didn't, then we wouldn't have to store it. We could just do that. But why are you calling a function if that returns something if you're not going to store it? This is called the argument. The thing inside the parentheses down here is the argument, and the argument fills in the parameter up here. They are two different things, right? That's a number. This is a variable. Now it's real easy to get them reversed, and when you're talking casually, I'll say, okay, I'm going to pass in 10 as my parameter. No, it's really the argument. Or really you can say, okay, I'm going to define calc and it's going to take 3 arguments. Well, really, those are parameters. So if you take a test or a quiz and it asks for the difference of an argument and a parameter, the parameters are defined in the function header, and the arguments are the values that you pass in. This one takes in 1 argument. That fills in x. X is used in this expression. Well, what's x at this point? 10 times 2 is 20, plus 10 is 30, and so r is equal to 30. So it's going to return 30, and that's going to get copied across the assignment operator into ABC, so it's going to print out 30 there. So return type is int, function name is calc, parameter list is int x. That's true about that. And then here, what's his return type? Somebody tell me. Int, right? Y'all know how to tell the return type now? It's the thing in front of it, just like a variable declaration. And his name is main. And his parameter list, none. No parameters. So if I ask you to write a function, we'll do that as an example later when we pop open Visual Studio. Function definition, the return type, I've already done that. He says that the line that reads int main is the function header. So that's the header of the function right there, int main. If a function returns a value, the type of the value must be indicated. Now what about functions that don't need to return anything? If you're printing something, you don't need to return anything. So you can declare a function as being void. Void means it doesn't return anything. I'm going to go back to my sample code here and do that. I'm going to declare a function called showMe. It takes a parameter, which is going to be a string called name. And what does it do? It displays the name to cout, but it doesn't need to return anything. Because when we're printing out somebody's name, we don't need a result. So show me Bob. So we're going to invoke the show me function. It will run up here. This argument here, Bob, it fills in that parameter. Now name is equal to Bob. That's its value. We print out Bob. We return. Notice there's no return word there as there was here. And my int main is incorrect because it doesn't have a return at the bottom. If you have a return type defined other than void, you need to return something of that type. So here we go. We don't have a return statement, but it wouldn't be incorrect to put one. I could do that, but since it's void, it doesn't return anything. I don't need to put a value after that return statement. In this case, the return keyword is optional. In the case of our calc function up here, the function is declared as type int, so the return has to return an int, or something easily converted to an int, like a byte or a character. So when you call a function, you give it the name, you give it the parentheses, and if it takes any parameters, then you put those parameters separated by commas within the parentheses. And when it is called, the program executes the body of the called function. When the function terminates, execution returns at the point of call. You can call more than one function in a row in the same line. Like here we had int ABC is equal to calc 10. We could do this. Int XYZ is equal to calc 1 plus calc 2. So as it runs along, this is going to be the first one it calls. It's going to jump up here, and what does calc return if we pass in 1 as an argument? 1 times 2 is 2 plus 10. So what's it returning here? What does this call return? I know somebody. Lindsay, you probably watched me step through it. You know what it returned, didn't you? You pass in a 1, so what does R wind up being? 12. Okay, so it comes back here. That returns a 12. Then if we do this again, calc 2 pops up here. 2, so it's 4. 2 times 2 is 4. Plus 10 is 14. So that one returned to 12. That one returned to 14. 12 plus 14 added together is 26. So XYZ would be 26. As usual, I'll keep popping up the recorder. Alrighty. The flow of control, I keep describing it, but here's a picture of it. Int main. See out hello from main. That's the first thing that happens, because when you run your program it looks for main and it runs it. That's the entry point into your code. If it sees a function, it jumps to the function and runs the body of that function. When that function is done, whether there's a return statement or not, it comes back and executes the line after the function call. So what is it going to print? It's going to print hello from main, hello from the function, and then back into function again. In that order. So we have this. Ignoring the fact that it doesn't have include statements and return 0 at the end of main. What is this going to print? Somebody tell me the very first thing this code prints. Is it 1, 2, 3 because AAA is up at the top? No, it's not. Why? Because what's the entry point to our program? Main. So it comes down here, and what's the first thing it prints? It prints 0, 0, 0. Then what's the next thing it prints? Yeah, AAA runs up here and it prints 1, 2, 3. So far, 0, 0, 0, 1, 2, 3. It's done with AAA, comes back here. Now what does it print? It calls BBB, but what's the first thing BBB does? Comes up here, prints 1, 2, 3 again. So far we see 0, 0, 0, 1, 2, 3, and then 1, 2, 3, comes back here, 4, 5, 6, and it's done with that. So that's called flow of execution in functions. It's like you can have flow of execution in if statements. When you have branching statements, something's executed if it's true. If it's not, then it's not.
I'm confused a little bit.
Well, then let's go look at it again.
I'm just confused about the concept of returning something. When it says voiding, that means it's not going to return something.
Exactly, it's not going to return anything.
But when you call AAA, it's clearly returning 1, 2, 3.
But it's not returning anything. To return something, I could do that, but there's nothing to return, so that would be a syntax error, besides the fact that X is not defined. The fact that it's printing something is not returning something. Those are two different concepts. Good idea, though. Let's do something a little bit different. Int Bobby takes X and returns 2 times X. Then int Sally takes X or Y or whatever. Variable names don't matter as long as you use them in the same way, and return Y plus 10. So down in main, int A is equal to Bobby. I really wish I'd defined one more, but it's okay. Int B, but we have to pass a value in, right? That would be a syntax error if not, because it's demanding an integer. So why don't we pass in 10 there? And here we're going to say int B is equal to Sally Bobby 10. Or let's pick a different number. 2. Like that. So for the first call, flow of execution is the entry point is main. Int A is equal to Bobby. 10 is our argument. Runs up here. 10 is being passed in. X is equal to 10. So what's it returning? 20. So 20 gets copied into A. Great. We print it out or something, whatever. Now, what's the first thing that happens in this one according to PEMDAS? Even though it doesn't look like a mathematical expression, it still is.
Bobby 2.
So Bobby 2 is the first thing that happens. So it calls Bobby, runs up here, X is 2 because that's what we passed in, it returns a 4. So now all of that is returning a 4 out of it. And that gets passed in to the Sally function as that argument. And so Y is equal to 4, return 4 plus 10. So all of this returns 14 out of that. So B is now equal to 14. Don't know if that helps or not. That flow of execution made sense?
That helps, I get it.
Yeah.
But what's the formal difference between a print and a return statement?
Print shows something on the screen, return sends a value back to the code. The act of printing is completely different from the mechanics of moving data around in the code, because you don't know how data is being printed. You don't know whether it's being sent to a printer or transmitted over the internet or being displayed on screen or whatever. It's calling a function, but we don't know the guts of the function. So it's not this has, whoops, where'd we go? That has no return statement, and we don't know how cout is working. We're just trusting that it's being displayed. That help?
Yes.
Okay. In Python, you didn't have to define a data type. This is just for your Python guys. Everybody else go la 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 la. You did this, and then when you called, when you called it, if you said X is equal to AAA, then by the time you were done, X equals that capital word none with the N capitalized. Everything in Python returns something, even if you don't add the return keyword yourself. If you don't add the return keyword, then it returns the value of none with a capital N. All right, everybody can unplug their ears. Do be able to follow that kind of logic, because that's kind of quiz question, test question, or whatever. If I said, tell me what A is equal to, you ought to be able to figure out. 10 gets passed into there, it returns it 2 times that, so by the time we get back there, it's equal to 20.
Along those same lines, I think I can understand why you would need to use an int than a void. Can you explain the opposite? Why you would prefer to use a void?
If you don't need anything back out of it, like this display method right here, why do you need to know? What is it going to return? You're not performing any calculations. There's no data of note.
But if I use an int there, I'll get an error.
You won't get an error, but you're going to have to return something. But what are you going to return?
Would it return 0? Is that
You could. That would work. But
just an extra line of code?
But then when you're calling it to display something, down in your code, you're doing that and you were hoping it was going to print 1, 2, 3. Are you going to do anything with that return value? You could store it into X, but then are you going to do anything with X? No. So if the function doesn't need to return any data because it's not returning any calculation or anything like that, just declare a void. Now, the C language, as opposed to C++, is notorious so that all the functions that they give you, at least at one time in the 70s, this may no longer be true, will return something even if it doesn't seem like it needs to. All the print statements return a value, even if that value is just 0. And usually people ignore that. They don't, say X is equal to print hello, because... But in general, if you're not performing a calculation, if there's no data of interest being generated there, there's no reason to have a return value, so you call it void. That makes sense? Halfway, 75%.
It does.
90.
It just, for the last couple of months, I guess I really never understood why sometimes we'd use void main or...
Right. Microsoft shouldn't allow main to be declared as void. That is a alteration of the standard. It's not standard. Main should always be declared as int, and the reason for that is so that if you have a scripting language like PowerShell or something else that runs that program, you might want to be able to check the return value. You can have programs that calculate a value and return it out of main so that the operating system can do something with it. And so the C++ definition is that main needs to be declared as int. But Microsoft said, well, we almost never return values. We're just going to allow you to set it to void because we're Microsoft and we can do things. Very, very good question. And if you go on to take Java, you're going to be doing a lot more with using functions in the definition of your classes, except you're going to call them methods, because a method is a function that's attached to data. Right now, these functions that we've demonstrated aren't attached to anything. They're just kind of sitting out there in outer space waiting to be called. So they're called functions. You can do object-oriented programming in both C++ and Java, and we will get to classes before the end of the semester so that we can do object-oriented programming, but you hit the concept earlier in Java, the way this textbook is structured. Function prototypes. Now we actually do need to crank up Visual Studio and start typing stuff so that we know why in the world you would use a function prototype. So here's our goal. We're going to write a couple of functions. And you don't have to type this, but what we're going to do is write a function called doubleIt, which takes an argument and returns 2 times the value, 2 times that value. Then we're going to write a function called times 10, which takes an argument and returns 10 times that value. Now I'm leaving out critical pieces of information. As a programmer, you're perfectly justified in sending the specs back to me and saying, I can't implement this because you didn't tell me what data types to use. You didn't tell me what kind of parameters to take and what kind of parameter to return. So then I roll my eyes and I grumble at you and I go, okay, the parameter is going to be, do I want to make it a double or an int? So parameter is of type int, and then the return is an int. Now we know enough about that function to actually write it. And we're going to do this in our code. And for the function that says times 10, why don't we make it take a parameter of type double? Parameter is double, and the return is double. And those are going to be the things that we do. This is enough information to write that code. I don't tell you the name of the parameter. On an exam, I might. You know, I give you this function definition, and I say the parameter is called a, or value, or something like that. If I don't tell you, that means that you can make it up. Pick whatever you want. So new project. Good old boilerplate. I'll erase you. I'll type it. And if you've already typed it in, great. If you cut and pasted, that's great. Right click, add new item. Except this time we're also going to be adding a header file, but we'll do that towards the end. Source.cpp. # include iostream, # include string, # include cmath for the Mac users, using namespace, std. Nope, I'm going to rough it again. No, I'm not. I get tired of typing that. All right, and then main, int main, parentheses, in parentheses, system. Mac users don't do this. System, pause, return 0. Good enough. So if you were going to write a program that would actually return a value to the operating system so that your scripting could determine whether an error occurred or not, you could return a non-zero value. And you could say that, okay, if it returns a 10, it means lack of disk space. And if it returns a 20, it means the internet is down or something like that. So that's why main has a return type. In some languages, it's not true. In Java, main is always void. The operating system can't get a return value out of Java. So let's actually create some methods. I gave us some specs for them. What was the first one to be called? Double it. Takes an argument, I didn't give it a name, returns 2 times that argument. It needs to return an int, and the parameter is an int. All right, let's do it. So, its return type is int. The name of it is double it. Parameter list, I asked it to accept a value of type int, so I'm just going to call the variable value. I did not specify the variable name, the parameter name in my specs, so you get to pick one. You could call it X or Fred or, Donnie, whatever. And now we want to return 2 times that value. It could just be as easy as this, return 2 times value. You can make it a little bit more complicated by declaring a variable that holds the return value and then returning it. And that is my preference. I don't care which way you do it. I'm going to define a return value called R, and I'm going to set R equal to 2 times the value, and I'm going to return R. Could have been done in 1 line of code, so why did I do it in 3? So that if I'm running the debugger, I could check the value of R before it gets returned. Or if I feel like adding a debug print statement, I could put a cout R right before that return and see what it's returning. Whereas if it was just one calculation, if this double it was 1 line long, I wouldn't be able to do that. All right, we had another one called times 10. I want you to go ahead and tackle that yourself. I'll bring the spec back up. Hope everybody can see that function we wrote there. Write a function that meets those requirements. Then I'll do it. When I say return is double, I mean return type is double. So what's the return type of this one? Double. What's it called? Times 10. It's going to take a variable of type double. Somebody tell me what they called the parameter. Did you do value just like we did on the other one? Yeah, all right. Remember, variable names are meaningless to the program. I could call this Barney as long as I use Barney everywhere consistently in it. Okay, so int r, I think I saw somebody do y or k. Int r is equal to 10 times the value, return r. All right, we're going to write one more, but I want you to put it underneath main. We never actually use those numbers, so let's go ahead and do that. You know, cout, double it, 10, ENDL, and then cout times 10, whatever you called your function, 10 ENDL, just to make sure it's all working. But we're going to write one more called square it. So cout, no quotes. We haven't written this one yet, so it's going to be a syntax error. I've got to run it before I start adding things that are going to break it, right? So I'm going to build it, build solution. It's giving me a warning, conversion from double. That's interesting. Oh, check that out. What should I have declared R as?
A double?
Yeah, all right. There we go. That'll get rid of that warning. I would have considered it an error. I wouldn't have minded if C# yelled at me about that, but it's a little more generous. And it's not as strongly typed as Java, for example. Alrighty, run it. So double the value of 10 is 20, and 10 times the value of 10 is 100. So that seems to be working. Anybody getting a syntax error, I'll come back and help you. Nope. Alrighty, so I want you to write it one more. My specs are going to be very short on this one. Write a function that returns the value of its parameter times itself, multiplied by itself. Call the function, square it. Now I didn't even give you a return type or anything. I ought to. So I think I'll just add a little clause in here, parentheses, parameter and return type double. So go for it. Write that one, but put it underneath main. And I'm doing that for a reason. I'm going to introduce a problem by doing that, and then we're going to fix it. And I'm going to go ahead and work on it myself. Double, square it, double value, opening brace, double R is equal to value times value, return R. Now in production code, if what you're doing can be done in a single line of code, are you going to put it in a function? Not likely unless it's a complex mathematical formula, you know, that you want to perfect and then be able to use over and over. So am I going to, would I really write a function called squared if I could just multiply value times value? Well, I guess I could, because POW to the power of 2 might be useful. Yeah.
I just, I put value times value without putting it into the variable. Is there a reason I should do that instead of this?
No, it works either way, except you better declare. Oh, I see what you did. I see what you did. That works. That works.
Okay.
All right, but cut it and put it below main, because we don't want it to work. We want it to break.
Okay. Put the whole thing below main?
Just to square it. Take that entire function, cut it, find main, find the closing brace for main, and put it underneath. Okay, so if I look at my code now, the way it's structured is I have 2 functions above main, double it and times 10, and then I have main itself, the main method itself, function itself, and then I have double square it underneath it. So when I try to call squared, it's going to be a syntax error. Let's prove it. Cout square it, the value of 20, because I want to see it say 400, right? 20 times 20 is 400. But it's going to underline this word square when I try to compile it and run it. So I'm going to choose build, rebuild. It gives me an error. Square, identifier not found. All right, so when you guys go on to take Java, you're not going to have this problem. But in C#, you have to define your functions before you can use them. What would the easy fix be? Grab that and move it up to the top. But I don't want to do that. I actually want to make this even more challenging. Go back up to the top and grab your double it function and your times 10 function. Just highlight all that stuff. Grab all of that stuff. Cut it. Edit cut. Go and paste it at the very bottom of your program, below main, below square. Now that breaks all 3 of these calls. Double it no longer works, times 10 no longer works, square it no longer works. So if I build it, it just has absolutely no chance of working. But we want it to work. We don't want to be dependent upon the idea that we have to have where our functions are defined in our code. We might even want to be able to put these functions in their own CPP file. So it would be really aggravating if we had to put them above main. But we do have to declare the functions, because otherwise the C compiler doesn't know what double it is supposed to take and what double it is supposed to return. And if it doesn't know what it takes and what it returns, it can't compile the code. So we're going to define it. Int double it takes an int. Double times 10 takes a double. We also made square it of type double. So double square it takes a double. These are called prototypes. And you Python guys haven't seen us do these. This is kind of a C specific, C++ specific thing. You Java programmers won't be using it, Python programmers won't, but in C, C++ you do. That fixes it. Now it will build and run. So what a prototype is it defines the header of the function, but it doesn't have the body of the function. And why do you do that? Because the function could be 1,000,000 lines long, you know, and you may want to put it into its own file. You don't want to cut and copy and paste it above main. So you need a way of specifying, telling the compiler, okay, double it, returns an int, and it takes an int. And that way, when it's ready to compile it, it knows what kind of machine code to build around that statement. Well, I'm going to be passing in an int and I'm going to return an int so that it can fix all that. So that's what's known as, that's a prototype. A prototype defines the header of the function without defining the body. Now, if you want, you can put variable declarations here. Instead of just int, you could put int value. And honestly, that's what I do. Double value, double value. Why? Because that name of that parameter may be useful. Right? If it was supposed to be a radius, don't type this, but you know, if it was supposed to be a radius, that is useful information to know that square for some reason is taking radius. Otherwise, I might have to go and look at the code to see why square, you know, was just taking a double. I wouldn't know. But at its bare bones minimum, these are the prototypes that would allow it to compile and run. And I guess now that I've said that, I better actually test it. Rebuild solution. Right. Project. Okay, there we go. Zero skipped. It worked. Run it. Okay, that's my expected behavior. Now say that we don't even want these functions in the same code. We want to make our own CPP file over here. We can do that. Let's make a different CPP file.
Can you go real quick down to the double it function?
Sure. And I didn't have the recorder going, so I'm going to repeat that. So I want to move those functions into their own files, so I'm going to do add new item from the Solution Explorer. It's going to be a C++ file. I'm going to call it myfunctions.cpp. All well and good. I kind of need those pound sign includes, but let's see if we can get away with not putting the pound sign includes. So I'm going to go back to source. I'm going to scroll down here. I'm going to get, square it, double it, and times 10. Just cut those. And then go and paste them into myfunctions.cpp. So I'm back in my main code, source.cpp or whatever you called it. Highlight all of those functions, square it, double it. Not the prototypes, but the actual good stuff, the code. Cut it. Go into myfunctions.cpp and paste it. Alright, I don't think I'm getting any errors because I don't think I'm using anything that requires any of those libraries. So I haven't had to add pound sign include anything up there. But if I was using cout or cin or strings or something, I would have to. Let's make sure it works. Alright, it's still working, even though those functions have been moved into a separate file. I'm going to go back to source now. What about these prototypes? Do I want to have to define my own prototypes every time I use those functions? No. Do you have to define all the prototypes for the string class or the math class or IOStream? No. Instead, you use pound sign include. Here's what I want to be able to happen. And so I'm going to type what I want to be able to happen, and then we're going to make it possible. What I want is for there to be a header file called myfunctions. Like that. It's giving me grief because I don't have a header file called myfunctions. So we're going to go and make a header file called myfunctions, and we're going to put those prototypes in it. So I'm going to come back over to source files. Check it out, there's a different folder called header files, although it wouldn't actually be an error if we put it there. I'm going to right click on the header files folder in Solution Explorer, do add new item, choose header file. And so this is going to be myfunctions.h. So I'm going to go back to my main code, grab those prototypes. And paste them into myfunctions.h.
Cut and paste or?
Yep. We want them yanked out of there. Now I'm going to go back to source.cpp, and I have a problem. And the problem is that I called the header file myfunctions.h, but my pound include just says myfunctions. So I need to make the pound sign include say myfunctions.h as well. Okay, as far as code goes, isn't that much cooler to look at than what we had when we had all those functions in the source.cpp? Yeah, as long as you could explain real quickly what double it times 10 and squared did, as long as they had a page full of documentation explaining what those functions did, then this is much clearer. So we have moved the prototypes to a header file, and we have moved those functions themselves into another CPP file. Now why would you do that? Because these functions may be so useful that you want to use them in another project. Just like IOStream. IOStream is really useful. We use it in all of our projects. Pardon me?
Is it supposed to run like that?
Should. Let me come look. I guess I didn't test it. Yeah, okay. Running for me. Let me come test it. So, there's an obvious difference in how we include that one and that one. Quote means find it in the same directory. So pound sign include quote means that myfunctions.h is in the same directory as our CPP file. So this is a preprocessor command, and what does it do? It grabs that file, this is during the compilation step, takes all of that stuff and puts it right here, like that. And so boom, it'll work. That's what pound sign include means. Copy that code and paste it into my source code, except it doesn't really paste it, no, but it acts like it is. You know, when it's being compiled, it does. So I'm going to undo those changes. That means that you could put anything in a .h file that you wanted to include. You can even write functions and store them in there. That's considered really bad taste, but you could. You could write a function here, int, you know, triple me, and stick it in your header file rather than put it in a CPP file. But like I said, that's considered really poor taste. Now, when you get to writing object-oriented programming, the urge to do that becomes much stronger, and it's not quite as strongly frowned upon. So the function prototype is a function declaration. It's the header without the body, and it ends in a semicolon. We put all of our headers inside that .h file. I'm going to ask you all to do this, and I'm not going to yell at you if you don't. I mean, count off points if you don't. But if you write a program and then you throw some functions in it, just to build up the skills, put your functions at the bottom underneath main, and then put some prototypes up top, okay? That just gets you better at it. I don't care at this point if you put them in a header file, you know, but just put your functions down here and then put prototypes above it like we did before we started cutting and pasting. Make a better programmer out of yourself. So your prototypes should be near the top of the program or in a header file. It doesn't say that. The program must include either prototypes or the entire function itself before any call to that function. Otherwise, you get a compiler error. If you use prototypes, you can put function definitions in any order. Doesn't matter whether you put them above, you know, main or below main. And otherwise, you get into this nasty situation. What if you had this? This would be weird. But what if you had this? Void function 1 calls function 2. Void function 2 calls function 1. Obviously, this is bad code. You wouldn't want to do this. But how would you get it to compile? Well, function 2 needs to be defined before function 1. All right, I'll move it up there. Whoops. Now function 1's not defined. I need to define function 1 above function 2. Nope. What I'm going to do, I'm just going to give myself some prototypes. Void fun 1, void fun 2. And like I said, is this a great example? Because would you write code that did that? No, because it would be an infinite regression, right? If you called function 1, it would call function 2, which would call function 1, which would call function 2, and it would do that over and over until it crashed. Sending data into a function. That's when you use parameters. You can pass values into a function, like the math function inside the CMath library. A to the power of b, these are arguments. So wherever they wrote the POW function, let's see if we can find it. Let's see if they gave us the source code for it. So I'm going to go into my code, and in main, I'm just going to do this. Double x is equal to POW 2 to the power of 3, right? I don't care what all those numbers are. Now I'm going to highlight the word POW, and I'm going to right-click on it and do Go to Definition. That should take me to the source code for the POW function. Hey, it kind of does. Boy, howdy, it's at a level that I don't want to see.
Some poor sucker wrote all that just for POW.
Yeah. Alrighty, so, but you can do the same thing for your own code. Like, what if you don't know what square it does? Highlight square it, go to declaration, go to definition, and boom, you can find out. That's a quick way of moving around in your code. I see an option I haven't used before called peek. I'm going to right-click one of my function names, peek definition. All right. I'm not sure why that's the best thing in the world, but I could look at it right there and then close it again. Bless you. So a function with a parameter variable. Here's a function they've written called display value. Takes an argument. Somehow I made 2 copies. There, okay. That's its name. It accepts a parameter, so you'd pass an argument to it. When it went in, it would print out the value is. And it would print out the value. And again, this is a example of something that doesn't need a return type because it's not going to return anything because all it's doing is printing to the screen. So a parameter, some textbooks do this, can be called a formal parameter or the formal argument. And the argument can actually be called an actual parameter. I'm not going to use these terms in my exam. Just tuck them away so if you read, another textbook or you're online or something and you hear the word formal parameter. Going back to our code, is this a formal parameter or an actual parameter? Arguments are actual parameters. AA, argument, actual parameter. So if we go into myfunctions.cpp, is value a formal parameter or an actual parameter? It's a formal parameter. I just like using the term parameter and then argument. That's the argument. It gets passed in. That's the parameter. It accepts the argument that gets copied into it. I like that terminology better. And if I ask something about it on the exam, that's the terminology I will use. But if you want to, you could call this an actual parameter, and you could call this a formal parameter. That just doesn't ring true to me. I mean, it doesn't make me feel better to say it. It doesn't impart any more information than using the term parameter and arguments did. So the prototype must include the data type of each parameter, but you can leave them out. Like I said, if this is the prototype for a function called even or odd, there's our parameter type, but we didn't actually give it a variable name. And that's okay because it's just a prototype. When you write your function, you better give that parameter a name, or else it's not going to work. But honestly, I like putting the name in there. I would actually put that there in my prototype as well as in my function. Because like I said, variable names mean something to humans. We might be able to get some information. And what do I mean by that? If, say you had a function prototype that looked like this. Don't type it because I'm just going to erase it. But what if we had a function here called double calc interest. And here's what it said. Int, comma, double, comma, double. Now you are a programmer who's going to use, why are you underlining it? Okay. You're told to write a program that uses the calc interest function. You go, what? What am I supposed to pass into it? I know that one needs to be an int, and one's supposed to be a double, and one's supposed to be a double, but I don't know what. So instead, what if it said int years, double principal, and double interest rate? Don't you know a lot more about what that function's doing now that you see those variable names? Yeah, you do. So when I define my prototypes, I typically include the variable names there as well. Strictly necessary? No. Delete. Alrighty. Function call notes. The value of the argument is copied into the parameter. Just like when I did that change me and I tried to set it to 1,000. Didn't work because all I got was a copy. And I think we're about done for today. The parameter scope is the function in which it is defined. I don't know if that's obvious or not. It seems obvious to me, but if you have a function declared like that, where can you get it? And say, I'm going to rename that. Like I said, variable names mean nothing to the computer, but they mean everything to us. Could we get to Bob outside of this function? Even if this was underneath it, could I do this? Could I say, int x is equal to Bob? No, I can't. Why? Because this is just like R. It's defined within that function. You can't get to those variables outside of that function. So Bob is local to the times 10 function. So I can't access it outside. That means that its scope is limited to the times 10 function. The scope of a parameter is limited to the function in which the parameter is defined. If you want to do something else with it, you better pass it in as a parameter to another function call. All right, that's about enough. Let's stop here. And any questions? Yes, sir.
All that code for the power function bugged me. Why didn't they just define first value asterisk asterisk second value?
Let's go look. Let's go look at it again. And I agree. It seems like overkill to me too, but let's go look at that POW function again. X is equal to POW 3 to the power 4. I'm not sure that'll work. I need to do it. Why is this giving me grief? Because I don't have C math included. So I'm going to move it over here into source.cpp where it originally was. Okay, it still is. Right click, go to definition. What it's doing is it's declaring POW functions that can work with all sorts of different data types in one fell swoop.
Oh, that one line is the function, not the whole thing.
Well, all of this is the function.
Oh.
But what it's doing is it's saying, okay, I don't care what type you pass me. You could pass me a byte, you could pass me a short, you could pass me a long, you could pass me a float, you could pass me a double, and I'm going to handle it. And so what it does is it wraps all the information in some way so that they can then call another function that they've written elsewhere that passes in that type, passes in that type. So let's go and dig a little bit further. And I'm honestly not going to be able to give you a really strong explanation of why it's written like this. But what they're doing is they're using what are known as templates to declare their types so that the function can accept more than one data type. So that you could write a function that would accept an int or a double or a long and only have to write the code once. But to do that, you have to go to some trouble, as you see. All right, it's not even letting me in to the definition of this kind of subfunction that it calls here. So that's tucked away somewhere else in some library we don't get to see, probably written in assembler for the fastest speed possible. All right, let's make a Dropbox and we'll be done.
I've got a quick question.
Yeah.
Which is more beneficial to resources, creating a separate function or pulling it from a separate CPP file? Which one is better for the resources?
Once it's compiled, it will run at the same speed no matter what. So, right, because all the CPP files get combined into one OBJ file. or at least a series of OBJ files, but then the linker comes and it sticks them all in one executable, and it didn't matter where they were defined, if that makes sense. Alrighty. Looks like I need to have some quizzes up. I don't see some quizzes. For chapter 5 and 6, is that the truth? I'll have those posted pretty soon. I'll go eyeball them right now. I'm surprised I don't have any up there yet. Anyways, by Thursday I'll have the quizzes posted in, and then you'll have adequate time to do them.
What quiz is that?
You can't see it yet because I haven't posted it yet.
I thought you already posted
Or have I?
quiz 5.
Alright, let me go look. I'm sorry. I'm lying to you.
Quiz 5 is up.
Quiz 5 is there, and quiz 6.
Not quiz 6.
Oh, quiz 6 right there. What do you know? Okay, let me let that be open as well. Alright. Good deal. Except I can't make quiz 6 due yet. But I'm going to make it open so you can go ahead and look at it. What do I mean by that? We haven't finished chapter 6, so why should I have it? Okay, but chapter 5 is open. So, one person's done it so far. Good enough. There should be a Dropbox. Let me go back and validate that I didn't leave it hidden or something dumb like that. It's there? All right. Good deal.